Oman, a tourist wonder in the eastern part of Arabia, has much to offer, not least its unique geology, which makes it a true geologist's paradise. We will take you through a journey across Oman, showing you its many geological marvels. Through varying landscapes of mountains, deserts, wadis, coastlines and others. From the highest peak in Oman of Jabal Shams, resting 3 kilometers above sea, we dive down to 3 kilometers below sea in the Sea of Oman, where we will start our journey. Here the collision between two continental plates occurs. Arabia gets consumed below Asia at a rate of 4 centimeters a year. As we head west, we climb the Arabian subcontinent. The sea depth changes from 3,000 meters to 100 meters in a short distance. At the northern tip of Oman, the Sea of Oman meets the Arabian Gulf at the Straits of Hormuz. As Arabia collides with Asia, the mountains of Musandam are sinking below sea at a rate of around 7 millimeters a year. As such, today's fjords are actually old wadis that submerged below the sea. Caves and hills once above sea today make sea life flourish and diverse. The journey continues south. The northern Oman mountains contain the best exposed oceanic crust in the world. These rocks are known as the Oman or Samail ophiolite. They form sharp and dark peaks. Some 80 million years ago, a large slab of the oceanic crust was emplaced on the northern side of Oman. Wadi al-Jizi reveals most of the story. These sausage-like forms are known as pillow lavas. They form when lava emerges on the seafloor and quickly chills. Not far from here, vertical features known as sheeted dikes represent the original position of the fissure in the rock into which the magma surged. Copper ore was mined since ancient times from Wadi al-Jizi. Current-day mines are present next to ancient mining sites. The weathered dark pebbles of ophiolite covers the area. Near Ibri, this debris emerges through narrow ridges of bounding white limestone as a spectacular fan. The ophiolite was emplaced on Oman along with deep ocean sediments. The best place to examine these sediments is in the Hawasina window. As they were transported from the ocean to Oman, the rocks were highly deformed and folded. Large, pale, exotic rocks, typical of shallow water, were formed above volcanic islands in the ocean. At the mouth of the window, hexagonal columns represent the slow cooling of lava sheets below the seafloor. East of here is Wadi Abyad. Two different units of the earth can be seen. The upper section is part of the earth's crust, whereas the lower, darker unit is part of the mantle. The line that separates them is known as the moho, which normally lies 8 kilometers under the ocean floor. Next to the moho, you can see the white water pools formed as the ophiolite naturally traps CO2 from air, converting it to solid soap-like carbonates. Along the contact between the ophiolite and the limestone of Jabal Akhdar lie a number of hot springs, such as Al-Kasfa in Al-Rustaq and Al-Hammam in Muscat. These springs emerge along a fault that separates the two rock masses. As rains fall, water percolates to considerable depths, gets heated and seeps back to the surface along the fault. Jabal Akhdar Massif separates Al-Batna from Al-Dahliya. The only road that connects the two sides goes through this window. As you drive along the road, you can examine glacial and limestone rocks deposited here more than 550 million years ago. The Snake Canyon of Wadi Bima cuts into these rocks. Trekking the wadi is a great adventure. This area is water rich. A number of mountain villages can be visited here. Beyond the wadi, you can drive up to Jabal Shams, the highest peak in Oman. The mountains here are formed of thick beds of limestone. As you reach this point, you will be enchanted with a view of the whole geological window. Below is Al-Huta Cave, formed by limestone dissolution. The wadi enters the cave from the top and emerges from the other entrance of the cave. Along the southern contact of Jabal Akhdar with the ophiolite lie a number of water channels. This is the underground channels of Falaj Daris. Along with 4 other falages in Oman, Falaj Daris is registered in the World Heritage List. This falaj is what is termed as a Dawoodi type, which taps into underground water sources at the foot of mountains through underground channels. Deep mother wells are sunk to tap into the source of water, and this is then conveyed to settlements on the plains through underground channels. The Dawoodi Falaj system requires sophisticated engineering and knowledge of the mountain geology. The road from Nizwa to Jabal Akhdar goes through Birkat al-Moz and Wadi Muaydin. Along the road, fish teeth and bones that date back to around 150 million years ago are present. In Saik Plateau, many sea fossils can be identified, including various types of corals, bivalves and sponges. The view here reveals the whole structure of Jabal Akhdar. This giant fold is more than 30 kilometers across, with glacial rocks forming the core, limestone in the flanks and ophiolite on both sides. The western Al-Hajar is separated from the eastern side by the Samail Gap, which is considered as the only easy access between Muscat and Nizwa cities. This is Jabal Sayhatat.